Hello student, last time we have seen the law of law of parallelogram for vector addition of two vectors. Law of parallelogram for vector addition of two vectors. Now we are going to learn resolution of two vector. Resolution of two vector in term of their component vectors. First one, try to understand resolution of vectors. Resolution of two vector. Resolution of vector or two vector. Resolution of vector. The splitting of single vector into two or more vector is called as the resolution of it. The process of splitting of single vector into two or more vectors is called the resolution of vector. Resolution of vector. Of, listen here carefully. The process of splitting of a single vector into two or more vectors is called as the resolution of vector. Next definition, resultant vector. Resultant vector. In this case, splitting of single vector into two or more vectors. Therefore, the single vector is called the resultant vector. Resultant vector. Component vector. Component vectors. These two or more vectors are called component vectors. These two or more vectors are called the component vectors. Component vectors. Listen carefully. Once again, resolution means the process of splitting of a single vector into two or more vector is called as the resolution of vector, and single vector is called as the resultant vector. Two or more vectors are called the component vectors. Means consider in xy plane. Suppose this is the xy plane in which this OP represent magnitude and direction of a vector A bar. This length OP represents magnitude and direction of vector A bar. Now this A bar is resolved or split up into two vectors. The vector along x direction is the AX bar. The vector along y direction is the AY bar. That is, we split up this A bar into two vectors, AX bar and AY bar. That is, AX bar along x direction, AY bar along y direction. Therefore, here assume that OQ represent magnitude direction of X bar and OR represent magnitude direction of AY bar. Means A bar is called the resultant vector, Ax bar and Ay bar are called the component of A bar along X and Y axis respectively. Let I cap is the unit vector. I cap is the unit vector directed along x direction. J cap is the unit vector directed along y cap. And therefore, how to write a bar in terms of x and a y bar? Therefore, a bar is equal to ax bar plus ay bar, or I cap ax plus j cap ay. In this case, a bar represents magnitude and direction of a vector a bar. Here I cap represents the direction of ax. Ax represents the magnitude of x bar. J cap represents the direction of ay bar. Ay representing the magnitude of ay. Means here we split this a bar into its two components, ax bar and ay. Whatever may be the vectors, we can split up two or more vectors, and this process is called as resolution of vector. And in this case, we resolve a bar in term of ax bar and ay bar. Let us determine magnitude and direction. Magnitude and direction of resultant in term of component vectors. Let a bar is the resultant vector represented by OP bar. Let AX bar and AY bar are the component vectors of A bar along X and Y axis respectively. Therefore, A bar is equal to AX bar plus AY bar. Equation number 1. Let I cap and j cap are the rectangular unit vectors. Rectangular unit vectors directed along x and y axis respectively. Therefore, a bar is equal equal to Ix plus Jay. Equation number 2. Equation number 2. Let theta be the angle made by A with x-axis. Therefore, in a triangle OPQ, in a triangle OPQ, in a triangle OPQ, OP square is equal to what? OQ square plus QP square, as well as cos theta is equal to OQ upon OP, sin theta is equal to PQP upon OP. In a triangle OPQ, cos theta is equal to OQ upon OP. OQ upon OQ. OQ is the magnitude of X and OP is the magnitude of A bar. Therefore, AX is equal to A cos theta. Equation 2. Equation 2. And sin theta is equal to PQ upon OP. QP or PQ upon OP, but QP is equal to OR. That is OR upon OP, but OR is the magnitude of AY upon A, and therefore AY is equal to A sin theta. This equation number 3. Listen carefully. In a triangle OPQ, cos theta is equal to OQ upon OP, but OQ is the magnitude of X. OP, length OP represents the magnitude of A bar A. Therefore, we get cos theta is equal to AX upon A. Therefore, AX is equal to A cos theta. Sin theta is equal to QP upon AP, but QP is equal to an parallel OR, but OR is the magnitude of AY. Therefore, sin theta is equal to AY upon A. Finally, AY is equal to A sin theta. Now, squaring and adding equation 2 and 3 and determine the magnitude of A. Let us determine magnitude of A bar by squaring and adding equation 2 and 3. We get AX square plus AY square. AX square plus AY square is equal to A square cos square theta plus A square sin square theta. Therefore, AX square plus AY square is equal to, here we taking common A square inside bracket cos square theta plus sine square theta, cos square theta plus sine square theta, but cos square theta plus sine square theta is equal to 1. Suppose this equation number 4. Therefore, equation 4 can be written as ax square plus ay square is equal to a square. Finally, a is equal to what? Under root ax square plus ay square. A is equal to ax square plus ay square. Ax square plus ay square. Listen carefully. From this figure, we determine the magnitude and direction of a bar in terms of their component x bar and ay bar. Let a bar is the resultant vector represented by OP, and their component ax bar and ay bar are represented by OQ and OP. Therefore, we get a bar is equal to ax bar plus ay bar. I cap and j cap are the unit vector along x and y axis respectively. Therefore, this equation can be written as a bar is equal to Ix plus Jay. Here I represent the direction of Ax bar, Ax represent magnitude of Ax bar, J cap represent direction of Ay bar, and Ay represent magnitude of Ay bar. Now in a triangle OQP or OPQ, cos theta is equal to adjacent side OQ upon diagonal OP. That means cos theta is equal to OQ upon OP. OQ is equal to what? AX. OP is equal to A. Therefore, cos theta is equal to AX upon A. Therefore, AX is equal to A cos theta. Sin theta is equal to QP upon OP. But QP is equal to OR is equal to AY. Therefore, we get sin theta is equal to AY upon A. And finally, AY is equal to A sin theta. From these two relations, means AX and AY, we can determine magnitude of resultant vector A bar. How to determine? By squaring and adding equation 2 and 3. Therefore, here AX square plus AY square is equal to A square cos square theta, A square sin square theta. Here we taking common A square, therefore AX square plus AY square is equal to AX square inside the bracket cos square theta plus sin square theta. But cos square theta plus sin square theta is equal to 1. Therefore, equation 4 can be written as ax square plus ay square is equal to a square, and therefore we get finally a is equal to under root ax square plus ay square. Let us determine direction of a bar in term of x bar and ay bar. Therefore, in a triangle OQP, this angle theta represents the direction of a bar. Let us determine the direction of a bar in term of their component in term of its component ax bar and ay bar in a triangle OQP. Tan theta is equal to QP upon OQ. QP upon OQ is equal to AY upon AX. AY upon AX. And therefore, theta is equal to tan inverse AY upon AX. This equation gives the direction of A bar in term of AX and AY. Once I told you that in a triangle OQP, tan theta is equal to QP upon OQ, but QP is equal to OR is equal to AY, OQ is equal to AX. Therefore, tan theta is equal to AY upon AX. Theta is equal to tan inverse AY upon AX. In 3D, in 3D, in 3D, AX bar, AY bar, and AZ bar are the component of A bar along X, Y, and Z axis respectively. Therefore, the magnitude of A bar is given by A is equal to under root AX square plus AY square plus AZ square. In 3D, A is equal to what? Under root AX square plus AY square plus AZ square. AZ square. Listen here, once again told you that the direction of A bar is determined by using angle theta in a triangle OQP. Tan theta is equal to QP upon OQ is equal to AY upon AX. Theta is equal to tan inverse AY upon X. This theta represent the direction of resultant vector R A bar in term of their component X and AY. But in 3 dimension, AX bar, AY bar and AZ bar are the component of A bar along X, Y and Z axis respectively. Therefore, the magnitude of A bar is given by A is equal to under root AX square plus AY square plus AZ square. इथं परत एकदा सांगतो, magnitude of resultant vector in term of their components A is equal to under root AX square plus AY square plus AZ square. थँक यू. कसं वाटलं लेक्चर? कॉमेंट बॉक्समध्ये लिहा. आवडलं लाईक करा, शेअर करा.